Now the next topic, that is power in LCR series AC circuit. Now see, we have the equation of supply voltage, that is Vm sine omega t, and current in the circuit at any instant, that is Im sine omega t plus phi, that we already discussed. Now in this equation of current, this Im, that is Vm upon under root R square plus Xc minus XL square, and this phase difference phi that we can calculate by the equation tan inverse Xc minus XL by R. So instantaneous power, that we can write V into I. Here voltage, that is also instantaneous, current, that is also instantaneous. So we can write V into I, that is instantaneous power. So V, that is Vm sine omega t, I, that is Im sine omega t plus phi. Now here multiply and divide by 2. So we can write Vm Im by 2 into 2 sine omega t plus phi. So 2ss, 2 sine. So for that, in trigonometry, you have the equation. As per that equation, here directly, this 2 sine omega t plus 5, that identity is written as cos 5 minus cos 2 omega t plus 5. Now, this one is the equation for instantaneous power at any instant t. But now if you want to calculate average power over one cycle, then we have to take average of this bracketed term. So average power, that is Vm Im by 2, that is constant part. So average of cos 5 minus cos 2 omega t plus 5. But this cos 5, that is also constant one in this bracketed term. So average power, that is Vm Im by 2 cos 5 minus average of cos 2 omega t plus 5. But average of cos 2 omega t plus 5 over one period, that is 0. So we can write average power, that is Vm Im by 2 cos 5. So we can divide these two in two part, root 2 into root 2, and Vm by root 2, that is Vrms. So we can say that is RMS voltage, and Im by root 2, that is RMS current. So now simply we can write the equation of average power, that is equal to V I cos 5, where cos 5, that is called power factor. That is called power factor. Clear to all of you? So this one is the theory of. Now the equation of average power P, that is equal to V I cos 5, where cos 5, that is called power factor. Means here we can observe this thing in LCR series AC circuit. Power not only depends on voltage and current, but it also depends on the phase difference between voltage and current. Phase difference between voltage and current. Okay. Now see here. Suppose the circuit is only the resistive circuit. It implies that inductor and capacitor are not connected in the circuit. So in that particular case, the phase difference between voltage and current, that is 0. So cos 0, that will be equal to 1. So in that particular case, the power dissipation, that will be maximum 1. But suppose we think about only capacitive or inductive circuit. So in that particular case, what happens? The phase difference, that is plus or minus pi by 2. So in that case, cos pi by 2, that is 0. So power dissipation will be 0. No doubt, current will be there in the circuit. But then also the power dissipation will be 0. So when the current is flowing in the circuit and power dissipation is 0, that particular current is called wattless current. That is called wattless current. Clear to all of you? And therefore, we use inductor or resistor to minimize the dissipation of power. And in case of LCR series circuit, in LCR series circuit, this 5 that we can calculate by tan inverse XC minus XL by R, and then depending on the value of this phase difference 5, we will get the dissipation of power. Clear? And when the resonance takes place in the circuit, so when resonance takes place at that time, XC equal to XL. So in that case, again here, phi that will be equal to 0. And when phi is 0, cos 0 is 1. So power dissipation will be maximum 1. And that is V into I, or we can write I square Z. But in this case, Z equal to R. So we can write simply I square R also. So in this way, due to which component in the circuit, how the power dissipation takes place, that we can understand. So if power factor is high, then the power loss that will be minimized. બરોબર છે? એટલે એક issue થાય. Then after B, power factor can often be improved by the use of a capacitor of appropriate capacitance in the circuit. Explain. Now see, that can be understood with the help of this particular graph. See, there is the phase difference between voltage and current, that is phi. Suppose we take this one is the voltage phasor, this one is the current, and the phase difference between voltage and current, that is phi. So now we can take two component of current. One is IP, another one is IQ. Okay. Now see here, this IQ, that is called wattless current, because that is perpendicular to voltage. And perpendicular to voltage hoy, તો voltage current એટલે particular IQ current જે છે એના માટે phase difference pi by 2 થઈ જાય. તો એનાથી power dissipation minimize or 0 થઈ જશે. એટલે આ wattless current થયો આપણો. Right? હવે આપણને શું કહ્યું છે એમણે? So power factor can often be improved by the use of the capacitor of appropriate capacitance. હવે power factor ને તમારે improve કરવો છે. Improve કરવો છે means કે you want to increase the power factor. તો increase કરીને કેટલો increase કરી શકો? તો power factor એટલે cos ની maximum possible value, that is 1. If you want to increase the power factor up to 1, then you have to make phi equal to 0. હવે આ જે ગ્રાફ છે એમાં તમને સમજ પડે જો આ phi ને તમારે 0 બનાવવું હોય તો તમારો કરંટ જે છે that should be only along V. તો તમારો phi 0 આવે. પણ હવે અત્યારે સિચ્યુએશન શું છે આપણી કે કરંટ અહીંયા છે એટલે એના બે કોમ્પોનન્ટ મળે છે. This IQ that give you the વોટલેસ કરંટ. તો હવે આપણે એક કામ કરીએ કે કેપેસિટર જોઈન કરીએ સર્કિટમાં. નાઉ કેપેસિટર, for that current lead the voltage in phase equal to pi by 2. So if we connect the capacitor in the circuit, તો હવે કરંટ જે છે એ વોલ્ટેજને લીડ કરે એવો એક મળશે તમને અહીંયા. તો અહીંયા જો તમને આ કરંટ મળ્યો કે જે વોલ્ટેજથી પાઈ બાય 2 આગળ બતાવ્યો આપણે, તો that is exactly opposite to IQ. તો હવે સિચ્યુએશન શું થાય કે this current and this current both are opposite અને મેગ્નિટ્યુડ વાઇઝ ઇક્વલ આવશે, કારણ કે કેપેસિટરનો કરંટ બી જે છે વોટલેસ કરંટ હોય ઓલવેઝ. તો આ પોર્શન કેન્સલ થઈ જાય, મીન્સ યુ વિલ ગેટ ઓનલી ધીસ કરંટ. અને આ એકલો કરંટ આવ્યો ધેટ ઇઝ ઇન ધ ડાયરેક્શન ઓફ વોલ્ટેજ, મતલબ કે ફાઈ તમારો 0 થઈ ગયો. So in this way you can improve the power factor. કારણ કે પાવર ફેક્ટર જો તમે મેક્સિમમ રાખો તો રિક્વાયર્ડ પાવર માટે તમારો કરંટ કંટ્રોલ્ડ રહે. જો પાવર ફેક્ટર તમારો ઘટી જાય, એટલે જો તમે ફેઝમાં વોલ્ટેજ અને કરંટ ના રાખ્યા હોય તો તમારો પાવર લોસ આવે. એટલે તમારે કરંટ એ વખતે રિક્વાયર્ડ પાવર માટે વધારવો પડે, અને જો કરંટ વધારો તો I²R પ્રમાણે ડિસિપેશન ચાલુ થઈ જાય તરત જ, એટલે લોસ વધવા માંડે ઇમિડિયેટ. ચાલો, ક્લિયર ટુ ઓલ ઓફ યુ?